You everyone for joining us tonight. I'm Sarah Frederick. I am the Eco Venture Coordinator at Rangeley Lakes Heritage Trust. This is one of our Dark Skies events that we've had planned for 2023. It is also part of our International Dark Skies Week celebration. So it's been happening since last Sunday. And we'll have a couple more events happening the next couple days to kind of finish that up. With that, I'm gonna hand things over to John Meter.
Thank you, Sarah. Hello, everyone. My name is John Meter, and I am the director of Northern Stars Planetarium, and I'm the vice president of Dark Sky Maine, which is a small nonprofit situated right here in the state of Maine to help preserve Maine's dark skies and help organizations like Rangeley Lakes Heritage Trust preserve your beautiful dark skies in the Rangeley area. And so I'd like to take you this evening on a tour of the night sky, the spring sky. So let me just move right over to that because you don't need to hear more about me. Let's talk about the stars. And we'll get that full screen here. And I'm going to get rid of my face so I don't look at myself while I talk. There we go. All right, well, this is the sky just a little bit ago, maybe 20 minutes, half an hour ago, because I wanted the sun up. This is the time of year, it's spring now, and after the spring starts, the days are longer than the nights. So the star we see in the sky most right now is our own star, the sun. So I thought we should start today, since we're going to see the sun a lot for the next few months, is talk about our star. You know, the stars outside at night are the exact same thing as the sun. So the sun just looks bigger and brighter and feels hotter because it's the closest star to us. It's the one that heats us up. We couldn't live without this star. And if we can learn how the sun works, then that tells us essentially how the other stars work. I mean, some are bigger and some are smaller and some are a little hotter and some are a little cooler. They vary, like we're all people, but we're not all the same height and weight. Stars are kind of like that too. So let's just start for a moment by just zooming in on our star, the sun. So here's the sun. The sun's an average sized star. There are stars much larger and much smaller. So it's not super big or super small. It's kind of super average. It's just special to us because it's the only star in our solar system. It's the one the Earth orbits. It has a surface temperature of around 12,000 degrees Fahrenheit, a little too hot for astronauts. But as hot as that might seem to be, that's one of the coolest parts of the sun. If you could go deep inside to the sun's core, you'd find it would get up to around 27 million degrees Fahrenheit. Hard to imagine it that hot. Now, what makes it so hot in there is the fact that the sun is really big. You could put 1,200,000 Earths inside the sun. So it's absolutely huge by our standards. And that means, and it's basically a ball of hydrogen gas. And an object that big has a lot of pressure. Gravity is pulling everything in towards the center. So every part of the sun is pushing in on the center. And that means the hydrogen in the center or in the core is being squeezed together so tightly that the hydrogen fuses together and turns into helium. That's called nuclear fusion. That's what happens inside a hydrogen bomb. In the core of the sun converts 600 million tons of hydrogen into 596 million tons of helium every single second after second after second. It's been doing that for 4.5 billion years. And as long as there's hydrogen left in the core, it'll keep on going. Scientists predict it should last another 4 to 5 billion years, which is good for us. We need the sun. We don't want it to die anytime soon. We'll see some examples of what the sun will look like when it does die as we get into the night sky here this evening. So 600 million tons to 596 million, that means 4 million tons have disappeared. Where does it go? It's converted to energy. Remember, E equals MC squared. So we're turning some of the mass of the sun into the energy, the heat, the light, and all the energy that flows out of the sun. All of the light and energy is created by those reactions in the core. And it flows out of the sun. And that's what heats our solar system. All the stars in the night sky are doing the exact same thing. So let's get to the night sky. So this is kind of the path of the sun is called the ecliptic, and I can put that right on the sky like that. As we go around the sun seems to follow that little yellow line. And in the course of the year, the sun, if you could see the stars behind the sun, which you can't because the glare washes them from our view, but with a handy dandy little program like we're using, we can shut the atmosphere off and you can see the sun is in a constellation. and it slowly moves through the constellations as we go through it. Those are the constellations of the zodiac. And we're going to follow the zodiac across the sky here this evening. But let's come back and bring our atmosphere back and let the sun set in a more natural way. We'll leave that line up because that's going to kind of be our guide this evening for a good part of our presentation. Let the sun go down. You notice it's setting north of west. And each night until the first day of summer, it's going to be a little further north than it was the night before. Let's let it go down a little quicker than that. Here we get to about 8:30. And the first thing you might want to look for, if it were clear tonight, it's kind of fun to see if you can see a really young moon. And you can see the moon is here in the sky, just off the ecliptic. By the way, the planets all follow along the ecliptic too. They're not exactly on that line like the sun is always on the line, but they're never far away. And the moon's somewhere along that too. It can sometimes be above it, sometimes below it. Well, tonight, if you had a clear night, you might, with a pair of binoculars, just get that little tiny thin crescent. We had a new moon yesterday, and on Wednesday night at 11 o'clock our time, or 11:30 our time, the moon went in front of the sun if you were in Australia, and there was a solar eclipse that took place. That's exactly the new moon. That was around 11:30 Wednesday evening Eastern Daylight Time. Well, now it's gone by there, and it's slowly waxing, which means it's getting bigger. Tomorrow night it'll be a thicker crescent. Tonight it's a very thin one, and you'll be challenged to find that if you had a clear night, because the sky is actually going to glow a little more than it shows in this program, and you might have to search for it with binoculars, and it's always kind of fun to see how young a moon you can find. Let's go a little bit later and darken that sky up just a little bit more. You see the glow is disappearing as the sun gets further below the horizon. Follow that ecliptic up, and the first constellation we're going to come to, let's just keep going just a little bit further. There we go. Is Taurus the bull. And Taurus is probably below the horizon right now. It's right here. This little triangle shape is the bull's face. We usually draw this as his mouth, perhaps, and the bright star Aldebaran is one of his eyes. You see a couple of big horns coming up here and coming back to a little clump of stars known as the Pleiades. Those are fairly young stars. They're maybe 70 to 100 million years old, and for a star, that's young. Remember, our sun is 4.5 billion years old, much older star. But the real object you want to look for in Taurus tonight is this bright thing. That's Venus. That's the first planet you're going to see, and it's the brightest thing in the sky that you'll see this evening. So Venus is right just beside Taurus's horns, just to the west of it a little bit. And if you look at Venus through a telescope, you're going to find it's kind of in a gibbous phase. That means it looks a little more than half, but not quite full. You never see a full Venus like you see a full Mars or a full Jupiter, because Venus is between us and the sun. And that means part of the nighttime side is always facing us. There are many times when you see a thin crescent, just like we saw that thin crescent moon a couple minutes ago. But right now, where it is in its orbit and where we are in our orbit, we're seeing what's called a gibbous. And that's where it's kind of egg-shaped. The thing you should know about Venus is is covered with clouds. So you're not seeing the ground here. You can't ever see the ground of Venus. It's totally engulfed in clouds. So if you lived there, you'd never have a sunny day and you'd never have a starry night. You wouldn't care though, because it's 900 degrees and you'd be fried to a crisp before you could stop and think about the fact that it's cloudy all the time, among other nasty things. Much prettier planet to look at than to visit. So let's zoom back away from Venus. One more interesting thing you might want to, if you have a telescope, want to explore in Taurus the bull, is just inside his left or eastern horn, right about in here. There's a fascinating little object, and it's called the Crab Nebula. Someone thought it looked like a crab. To me, it looks like an explosion, which is actually a very descriptive thing, because that's exactly what this thing is. The Crab Nebula is what's called a supernova remnant. This is a star that exploded, and we know the exact day it exploded because the Chinese wrote about it. It exploded on July 4th, 1054 AD. That's about 970 years ago, give or take a few years. So when it exploded, this star was a much more massive star than the sun. The sun will never explode like this. For a star to explode, it's going to be pushing at least 8 to 10 times bigger than this, more massive than the sun. And the sun seemed pretty big. The star was way bigger. And when it got to the end of its life, it wasn't no longer making helium in the core, it's making iron. And once you start making iron, it takes more energy to make iron than it can give off. And the star collapses on itself. When it collapses, it creates one giant fusion reaction that in 1 second can give off more energy than all the rest of the stars you can see combined in that same second. And in that process, that giant explosion, it creates everything that's heavier or denser than iron, like gold and silver. So if you have a gold wedding band on, or silver earrings, or any gold or silver coins, all the gold and silver on the planet Earth was created in an explosion like this. So if you fondle your wedding band the way I am right now with mine, you should realize you have a piece of a supernova wrapped around your finger right now. Isn't that cool to think about? Well, that's a giant star that exploded just under 1,000 years ago. And you can see what's left of it today with a telescope in the form of the Crab Nebula. Now, underneath Taurus is a constellation that's very famous, which we're only going to see just for another week or two, and then it's going to kind of disappear. It's already getting pretty low in the sky, and that's the famous Orion the Hunter with the 3 stars in a row for a belt and 2 legs coming down. Its body up here with a head on top, an arm with a club, and an arm over here with a shield. You imagine him as pictures like this, you can see that it looks like he's fighting with Taurus the bull. There are lots of stories about Orion fighting the bull, maybe trying to save the 7 sisters. Some say that the bull's trying to save the 7 sisters from Orion. Lots of different stories about these characters, but they do look like they're in the midst of battle. But we want to kind of stick as much as we can. We're going to go off a little bit from the zodiac. But I wanted to point out Orion because it is such a famous constellation, and it's a really, really nice one that's easy to find, and it's right in front of Taurus the bull. But if we follow that zodiac to the east from Taurus, if you know your zodiac, you know the next constellation is the Gemini twins, Castor and Pollux. This one is Pollux, and this one is Castor. They're 2 twin brothers. You see they're clearly not identical. They must be fraternal twins because one's got a short body and long legs, and one's got a long body and short legs. So but they do kind of look like 2 stick people with them holding hands in the middle. And it's a pretty distinctive little constellation. And it's one like Orion that I think does a pretty good job for a dot-to-dot picture what it's supposed to be. What you want to look for in the Gemini twins right now is this red star between the 2. That's not a star. That's the planet Mars. So let's zoom in on Mars. Mars is right there. And you want to be careful when you go outside. If you just look for a red star, you're going to see this shoulder in Orion. Now, my program here doesn't look very red, but outdoors, it's got a very deep red color. It will definitely stand out as a reddish orange color, about the same color as Mars. Back in December, Mars was significantly brighter than this red star. The red star in Orion's shoulder, by the way, is named Betelgeuse. And it was brighter than Betelgeuse. Now it's about half as bright as Betelgeuse. That's because planets move. They move around the sun, and the closer they are to the sun, the quicker they go. Well, Earth is closer than Mars. And since December, when Mars and Earth are relatively close together, making Mars bright, Earth is pulled away because we move faster. And as we get farther from Mars, it gets dimmer. So it's much dimmer now, and it's dimmed down fainter than Betelgeuse. And Betelgeuse is pushing 800 light years away. So the distance by our motion, it hasn't really changed its distance away from us in any significant way. So its brightness has stayed consistent. Well, let's look at Mars. Let's go in and take a look at that. We only have these 2 planets to see tonight. Mars is interesting. You won't see with a backyard telescope the detail you're seeing in this image. It's much fuzzier. It was better back in December when we were closer to it, but even then you probably wouldn't see quite what we're seeing here. The one thing I always look for when I look at Mars are these white spots. You see one at each end. Usually you see one or the other. You don't often see them both. Those are the ice caps at the North Pole and the South Pole. Now we have ice at our North and South Poles here on the Earth. Our ice is all made of frozen water. Some of the ice at the poles of Mars is actually frozen water too. But most of the ice you're seeing is not frozen water. It's frozen air. Mars has an atmosphere of carbon dioxide, and at the poles, it gets cold enough so that air sublimates into ice and it falls to the ground. Imagine it getting so cold that the air freezes. That happens on Mars and around the poles, that is. And in the summer on Mars, those ice caps get smaller, and in the winter, when it gets colder, they get bigger. And that's mainly the carbon dioxide ice, the dry ice, as we call it, sublimating and then freezing back down to the surface again. So always look for that. The red color, reddish orange color on Mars, by the way, is because of rust. Mars's soil and rocks are filled with particles of iron that's combined with oxygen, creating iron oxide, which is simply the scientific name for rust. Mars is a rusty planet. So those are the two planets you can see tonight, Venus and Taurus the Bull, and Mars. Well, they're both moving. And as I told you, the closer you are to the sun, the faster you move. So which one moves faster? Remember, it goes Mercury, Venus, Earth, Mars. So Venus moves faster. It's catching up to Mars. They're both moving eastward through the sky. And in the course of the next couple months, they're going to both move from Taurus and Gemini into Cancer the crab. Now that doesn't look much like a crab, does it? Crabs have 8 legs and 2 claws, but the story shows that the crab was kicked by Hercules when Hercules was fighting the Hydra. Hera sent the crab up to distract him, and Hercules gave him a swift kick, and a few legs went here, a few legs went there, and so our crab's down to 4 legs. Pretty sad-looking crab, but I guess that's what happens when you get kicked by the strongest guy in the world. So they're both going to move through Cancer in the course of the next month and a half or so. And I forget the exact date. I think it's sometime in May. They're going to be right in the center of the crab is a beautiful little cluster called the beehive. Let's check it out. And they're both going to move very close to the beehive. So if you're a photographer like I am, when Mars gets close to the beehive, I want to get a picture of Mars in or near the beehive because it's going to stand out because it's got that red color in the beehive. It's all these young stars that are all relatively close together. It's very, very pretty to see. And these stars, this is an open cluster of stars, kind of like the Pleiades were. And this one is about 577 light years away, 23 light years across. Now, remember, a light year, it sounds like a length of time, but it's not. It's a distance, like an inch is a little distance. A mile is a bigger distance. A light year is simply the distance a beam of light will travel in a year's time. And light travels at the incredible speed of 186,000 miles per second. So if you travel at 186,000 miles per second for 1 year in a straight line, you're going to cover some miles. That distance is 1 light year. So this object across, the field of this cluster of stars, that's about 23 light years in diameter from, let's say, here to here. And it's about 577 light years away. Well, Mars is much, much closer. It's not really going through those stars. It's going in front of those stars. And so will Venus in the next month and a half. So that's a beautiful little spot to see. This goes by a couple other names. It's also called Precipice. It's also called blanking out here. The Chinese referred to it. I'm the one I was trying to think of. I've lost track of. The Chinese referred to it as the exhalation of piled up corpses. I don't know exactly where that came from or what that's supposed to look like. Sounds pretty morbid to me, but this is a cluster you can see with just your eyes. You won't see all those stars with your eyes. It's going to look like just a fuzzy little patch in the sky. And maybe that's the idea of an exhalation, like breath coming out of something, or who knows. But that is one of the terms it goes by. So Mars and Venus are going to meet up in front of our next zodiac constellation. And if you know your zodiac, we went from Taurus to Gemini to Cancer the crab. And the next one's Leo the lion, and he's right here. Now, this is only a partial drawing of Leo. You see the sun just goes kind of right underneath him right here. To see Leo, what you want to look for first, I'm going to shut the lines off for just a second so we can just see him. Let's shut the ecliptic off for a second, too. The first thing you look for is what we refer to as the backwards question mark. It starts here, goes up to the star and over and down to Algebra, over to the star, then down to Regulus for a dot. Kind of looks like a question mark, but it's facing the wrong way. So the question is, how do you turn that into a lion? Well, you add a few more stars. So think of this as the mane on the back of the lion's neck. Over here would be the face. There aren't any bright stars to mark his face, so I always tell kids you just have to pretend that part. Then we come back to these two stars, Zosma and Cherton, and then up to Regulus, and then back. And this is the lion's body. They don't give the legs, but there are legs here. There's a leg to here and a leg down here. So those are the two front legs. Come back to the belly, and there's a back leg here and a back leg there. And this is a tail. I don't usually draw this line in because lions' tails are a long, thin tail, not a triangle, but you often see it drawn as a triangle. But I just like to draw this line and leave this one out. Let it be a tail down to the bright star de Nobla, which is an Arabic word, which refers to the tail. And I think it actually kind of looks like a lion if you use your imagination a little bit. And what's going to happen is around the 4th of July, Leo's going to be way over in the west by then. But remember, the planets are moving eastward. And so they're going to meet up right in front of Leo the lion. You're going to find Mars and Venus very close together right here in front of Leo. So around the 4th of July, if you get out that night and you've looked at the fireworks and the stars are coming out, look over in the southwestern sky, you'll see Leo up there, and you're going to see very bright Venus and a very faint Mars right beside it. They're going to be side by side, but Venus is going to far outshine Mars because Venus is a lot closer, and we've moved even farther from Mars. So it's going to be even fainter, not invisible, but fainter. So they're going to move right into here. So that's, again, is right along the path of the sun. So the sun follows this across the sky. So you might say, well, I'm a Leo. And if you're a Leo, then you're born in late July or early August. That's not a good time to see your constellation. The best time to see Leo is 2 or 3 months, a couple months before, like in April, in May, in June. Because the reason you're a Leo is because when you're born, if you could see the stars behind the sun's always in a constellation. The sun is within the constellation of Leo. And remember, the way we designate constellations, we draw these pictures to help visualize them and find the group of stars. But everything inside these red polygons, everything inside this one is part of Leo. So you see the sun actually travels through quite a bit of Leo right here. A little bit less of Cancer. It's a smaller constellation. And right through the Gemini twins and right between the horns of Taurus, the bull. So it's on your birthday, if you're a Leo, it's because the sun is somewhere between here and here. So you can't see your constellation on your birthday. Now, there are some cool things to see if you get out between now and then and look for Leo. We've seen some interesting things like the dead star in the Crab Nebula in Taurus the Bull. We saw the Beehive cluster of fairly young stars. And those stars are fairly young stars, maybe a couple 100 million years old. That's kind of like teenagers in the starry age. And just like teenagers who like to hang out together, so do young stars. And that's what we found with the Beehive. Get over here in Taurus, we're getting into a part of the sky where there are lots of galaxies. We moved away from the Milky Way. This time of year, it's hard to see the Milky Way in the evening sky. And when in the part of the Milky Way, it's hard to see other galaxies because the Milky Way itself is so bright. Here we're looking kind of out the side of the Milky Way, and there's some great galaxies. And I want to show you a couple. Right under Leo's back leg, right about in here, is what's called the Leo triplet. And they're right here. If you look carefully, they're right over here. And there are 3 galaxies. And in a small telescope, you can get all 3 galaxies of the Leo triplet in one field of view. Now, this one right here is called M65. This one's M66. And this one, M stands for Messier, Charles Messier, back in the 18th century. He was someone interested in comets. He was constantly trying to find new comets in the sky. And in the telescopes back in those days, and frankly, many telescopes today, comets look like little fuzzy patches. You don't often see a tail unless it gets really close. But they know they're comets because they slowly move through the stars. Well, these things in small telescope look like little fuzzy patches too. Sometimes comets look just like galaxies. And so he cataloged these, and he knew they weren't comets because they didn't move in relation to each other or in relation to the stars. And so he cataloged these things. He made a list of 110 of them. So this one here is M66, and this one's M65. No, I'm backwards. This is M65 and 160, M66. The one above it is called the Hamburger Galaxy, or NGC 3628, if you want to have a catalog number for it. Someone called it the Hamburger Galaxy because I guess it has those dust lanes. We're looking at an edge on. It's a spiral galaxy. So think about a spiral. I'll show you a face-on spiral before we're done here. And spiral galaxies are kind of shaped like frisbees. They're round, but they're kind of flat. This one you're looking edge on. So take a frisbee and look at it edge on, and you kind of look like this. And it's got a dust lane going through it. A bright spot. Most galaxies have a very bright core, and you can kind of get a hint that there's a bright core in there too. Then a halo of stars all the way around it, making this haze. Now, the other two down here are kind of interesting. Let's look at M65 first. Now, M65 is a spiral galaxy. We're looking at it about maybe a 40-degree angle or something like that. So you can see the core here, and you see the spiral arms coming out. We're not looking straight down at it. They're situated in all different angles in the sky. But you see how it's bright here, and then you see the dust lanes and things again, and all the light you see is the light from stars. Now, when we go to its companion M66 on the other side over here, you're going to notice something very different when you get over to this one. You can see lots of pink and blue patches, which we didn't see in M65. Those pink patches are places where stars are being born. They're giant clouds of hydrogen gas. So are the blue ones. The difference is the blue ones, the stars aren't quite as close together to the gas, and the light's lighting them up the way you shine a flashlight on something and light it up. And when the stars light up something by shining on them, the hydrogen gas tends to glow with a blue light. Where it's red, it's because the stars are closer to the gas, and these young stars give off lots of ultraviolet light. And that stimulates the hydrogen enough so it's not just being lit up, it starts to glow on its own. And when it glows with the pinkish red light. So these are all areas, these blue areas and red areas, they're really the same thing. It's just a matter of what kind of light is shining on them and how energetically it affects the gas. These are regions where stars are being born. And if you could hang around for maybe 100 million years, where you see these pink patches, would end up being little clusters of stars like the beehive we just looked at. Now, why does this have so many star regions and this one doesn't? Well, scientists have discovered that this one, M66 and the Hamburger galaxy, if you study their motions, because everything is moving in space, they have interacted with each other. And when galaxies interact and they kind of go by each other, their gravities kind of tug and swerve, and it kind of stirs up the hydrogen that's floating loosely, and that gets star formation going. Galaxies that haven't interacted with other galaxies tend not to have as many star forming regions. So when galaxies interact, they create regions for new stars to form. We find that's true with these two. And they believe those two were interacting about 800 million years ago, and they're moving away from each other right now. So it's a really beautiful place to look and explore. Lots of galaxies in these regions, but these three are just a nice little angle, a nice little pocket. You can see all three of them at once in a small telescope, and they're all spiral galaxies, but kind of looking at them all in different angles, and you see that different things are happening in different galaxies. So that's right under the hind leg, just behind the hind leg of Leo the lion. Well, let's go down. The next constellation of the zodiac is Virgo the maiden. Now, I don't really like the way they draw Virgo here. Let's see how they draw it first. And it doesn't make her a very attractive young lady, in my opinion. She kind of, I don't know, looks like a robot or something to me. So I'm going to take off the lines and see if we can see it the way that I draw it, which I think is better, but maybe I'm prejudiced about that. Let's get rid of the lines here. So this star right here is called Parima, and that's Virgo's shoulder. Now what I'm going to draw here for you is just a stick person. Let's get rid of that line too. So to see her as a stick person, think of Parima as her shoulder. Come down to this star right here, and that's her body. Just draw a line there for a stick body. She's got an arm coming up like this, and an arm coming down here to the bright star Spica. That's the brightest star in Virgo, the maiden. This one right here, Spica. It's a blue star. So we've got an arm here, an arm there, a body. This star is her head. Come down her body, she's got a leg right there and a leg right there. Real simple stick person. I wish I could draw those lines the way I like to draw them, and I think it would make more sense. So with the lines here, just draw a line here and ignore this one and erase that one. She's got an arm, and I just go up to here as her head. You don't need to draw this one. And then she's got a leg here. And then I draw a line from here to here for the other leg. And I erase those two. You can draw it any way you want. I frankly don't see this very well that way. They draw this fancy picture like that, and I don't even begin to see that young lady in those stars. But that's Virgo the maiden. She's often referred to as being Persephone in mythology. And Persephone, if you know your mythology, she was the daughter of Demeter. Demeter was the goddess of the harvest, and she helped sow the seeds in the spring. And she was harvesting in the fall. Persephone was helping her mother harvest the wheat, and she had a big sheaf of wheat in her hand. And Hades, the god of the underworld, had come up and saw her, and she was so beautiful. He fell in love with her, and he kidnapped her and took her to the underworld. And she carried with her that shaft of wheat. And the word spica refers to a sheaf of wheat that she's holding in her hands. And so she was the underworld. She doesn't like it down there and makes the deal that, she didn't die. She should be able to go back and be above. And Demeter makes the deal that she can come up. And to make a long story short, Hades gives her a pomegranate and tells her not to eat any of the seeds. Well, she ends up eating half the seeds. And so she kind of broke the deal. But since if she ate all the seeds, she'd have to stay down in the underworld forever. But since she ate half of them, she only has to go for half the year. So when she goes to the underworld in the fall, because she ate the seeds, her mother gets sad and the world gets cold and the crops all die. But 6 months later, she's allowed to come back up in the spring, this time of year. That's when she appears in the sky. And that's when the weather gets better and the crops begin to grow. And so you can thank Virgo for the fact that all the leaves are starting to come out soon. So that's Virgo the maiden right there. So these are the constellations of the zodiac we can see right now. And you can see there's the path of the sun traveling right through those constellations, from Taurus the bull to the Gemini twins to Cancer the crab to Leo the lion, and then over here to Virgo the maiden. Now, there's another way to find these. The ones over here, the Gemini twins, are best found, and Taurus using Orion the hunter, perhaps. But if you want to find Leo and Virgo, there's an easier way. And that's we have to get off the ecliptic and look high overhead in the spring for the Big Dipper. The Big Dipper is right up here. The Big Dipper, as you may know if you've joined me for these before, the Big Dipper itself is not really a constellation. It's what we call an asterism. It's a group of stars that's easy to recognize. It's these 3 stars for a handle, and then these 4 stars making a pot or the bowl. To me, it looks like a pot you'd cook with on the stove. Here's the handle you grab, and you put mac and cheese in there and get lunch going for the kids, right? Now, officially, the Big Dipper is part of Ursa Major, the Great Bear. To see the bear, the handle becomes the bear's long tail. And if you know anything about bears, you know they don't have long tails, but there are lots of stories explaining how the bear in the sky got his long tail. The Dipper plus these 2 stars make his long body with a nose way out in front, a couple front legs here and a couple back legs there. They got a weird looking bear. That's why we generally settle for just the Big Dipper. It's really just the easiest thing to find there. Now, the Big Dipper has a couple of interesting things too. Remember, we just talked about galaxies, and we saw galaxies edge on and kind of at a 45 degree angle right above the handle of the Big Dipper. See the handle right here. Go to the last 2 stars. Right about in here is one of my favorite galaxies. Let's see if we can zoom in on it. Come right over here. It's going to zing us around. That's what I wish it didn't, but it does. We're going to see M101. And M101 is called the Pinwheel Galaxy. And this is a spiral galaxy, but we're not looking edge on. We're looking face on now, where it's like right flat in front of us. And you see those spiral arms coming out here. See the spiral arms, and they're all made of stars. There are planets and things in there too, but that's not what you're seeing. Planets don't give off light, they reflect light, and they're tiny compared to stars. So what we're seeing here is the light of stars. And you see this galaxy is way bigger than our Milky Way, about twice the size of the Milky Way. So some galaxies are bigger, and this is definitely one of them. It's about 170,000 light years in diameter, very large galaxy, about twice the size of the Milky Way. It's about 25 million light years away. So when you look at this, what that means is that when you look at this through a telescope and you see these spiral arms, what you need to realize, the light that's coming into your eyes at that moment left that galaxy 25 million years ago. It takes the light that long to get here because light can only travel at the speed of light. And so for the speed of light, that means it takes light a year to go 1 light year, 2 years to go 2 light years. Well, this is 25 million light years away. So you're seeing it not as it actually looks today, but how it looked 25 million years ago. And if there's a planet somewhere going around one of those stars and they've got a telescope and they can look towards the Milky Way, if they had a telescope, because aliens always have better technology than us, right? Let's say they had a telescope powerful if they could see people on the Earth. Could they see people on the Earth? No, because when they looked at the Earth, if they could see it, they would see it the way it looked 25 million years ago. Now, that doesn't mean that they might see, cave people, perhaps. They might see saber-toothed tigers. They wouldn't see dinosaurs. Dinosaurs died 65 million years ago. This is only 25 million light years away. So somewhere in between there's the Earth they'd be looking at. This is older than the pyramids and older than Stonehenge. They'd be all before that. So when you look at things far away like this, you're really looking back in time. And if you look at this galaxy, you notice there's a lot of pink in here too. So there's a lot of areas of star formation. Maybe it collided with something else a while ago. We don't see any other galaxy nearby that it might have collided with immediately, but there's definitely some star formation regions here too. And while our galaxy has about 200 to 300 billion stars, this galaxy has about 1 trillion stars in it. That's a lot more. Maybe some of you heard this, but I always find this fascinating. So bear with me for a moment. I find that kids, when I teach kids, they don't understand the difference between 1 million and 1 billion and 1 trillion. They all kind of sound the same. Think about this. 1 million seconds. A second is something we can all comprehend. 1 million seconds is 11.5 days. So for kids, this has been school vacation week here in Maine. That's like the length of time for a vacation week, a week with a weekend on each end. That's about 11.5 days. So that's 1 million seconds. We can comprehend that. 1 billion seconds is 31.5 years, a little bit longer time. And 1 trillion seconds is 31,500 years, an even bigger, much longer time. So this galaxy has around 1 trillion stars in it. So just try to comprehend how many stars that actually is. That is a beautiful sight right there. Now, coming a little closer to home, I did tell you that I was going to show you a place where a star has died. We saw how a big star died, like the Crab Nebula. And I said the sun wouldn't die that way. The sun, when it gets old, about 5 billion years from now, its core is going to be all helium. There won't be much hydrogen left. And the fusion reactions slow down. When it slows down, gravity is still constant, so the sun's going to start to shrink. Pressure builds up and the helium in the core will start fusing together, turning into carbon. And around that, there'll be a shell of hydrogen that fuses into helium. It's going to swell up again. It'll swell up big enough to swallow Mercury and Venus. Might reach the Earth. Somewhere in there, it's going to find an equilibrium for a few million years. When the core is all carbon and the shell's all helium, then it's going to shrink again. And there won't be enough weight to a star the size of our sun to fuse carbon into anything else. But outside those two shells, the core and the shell of helium now, fusion starts happening again. And it's about halfway from the core to the outer edge. And when it pushes out, it actually just pushes the outer layers away. Not a giant explosion like the Crab Nebula. It just pushes it away and it goes floating off like an envelope of gas floating away. Well, right here underneath the Big Dipper, right about in here, see how close I can get. It's going to be right near that star. We're going to find a star. It's right there that died. This one's called the Owl Nebula, and you can probably see why it's called that. These are called planetary nebulas. They have nothing to do with planets. But in 1781, William Herschel discovered the planet Uranus and promptly named it George after King George. Well, the name didn't stick, but the planet was very exciting to discover a new planet. And lots of people started hunting for planets. Well, there are these types of nebulas scattered all over the sky where stars like our sun have died. And they tend to be very round, as you can see this one is, and easily confused with planets. So people started finding them, but planets, remember, move like we talked about. These don't move. But people confused them with that, and so they started calling them planetary nebulas because it reminded them of planets, but they were clearly nothing to do with planets other than the shape. What we now know planetary nebulas are medium-sized stars that have died and pushed their outer layers out. These outer layers are expanding outwards from the center at about 1,000 miles an hour, which sounds pretty fast. But when the star explodes like the Crab Nebula we saw, it's expanding outwards at over 1,000 miles per second, much, much faster. So this is how our sun will die in about 5 or 6 million years from now. Not something to worry about in our lifetime, but it will happen one day. This object is about 1,300 light years away, and this star died about 6,000 years ago. So that's not that long. Longer ago than the Crab Nebula, but back when we've seen things that are much further away than this and much, much older. So these tend to very often have this bluish aqua color to them, which is very, very distinct. They don't always have these two dark spots, and that's where the term owl nebula comes from, because someone thought those like the eyes of an owl. But it's a beautiful one to look at. It was discovered in 1781 by Pierre Michon in France, I believe. You can see another little galaxy right over here beside it. If you find the Owl Nebula, just kind of scan over this way and you'll find another spiral galaxy, almost edge on. This one sometimes is referred to as the Surfboard Nebula or the Surfboard Galaxy. It's known as M108 of the Messier catalog we told. And it's about, I don't have the distance, 47 million light years away. So it's much further away than the last couple we've been looking at. So some interesting things there, right? That's right underneath the pot of the Big Dipper. We kind of swung around upside down here. And this time of year, the Big Dipper is getting higher and higher in the sky. Now, I said I was going to use this Big Dipper to find Virgo and find Leo and all those things in a new way. So we have to find one more constellation. Follow the arc of the handle. See how the handle curves? If you follow that arc down, it points you to a bright orangish white star. It kind of looks orange outdoors. That star's name is Arcturus. To Arcturus. And Arcturus is in this funny looking constellation shaped like a kite. It's called Boötes. And Boötes is a herdsman. It's a picture of a man. And he is also known as the bear chaser, because remember, Ursa Major is the great bear. So let's shut these off for a second. And let's just bring up no, that's not what I want. Shut them all off. And bring up just the bear. And bring up just the bear chaser over here. Come on back. There we go. There he is. Now, so if you use the fancy pictures, you can see there's the guy and there's the bear's looking back over his shoulder at Boötes. Now, I have a hard time making that look like a bear. It looks much more like a cooking pot. And the other one looks more like a kite or perhaps an ice cream cone. We often draw it as Boötes, the ice cream cone. Arcturus is the point, and we draw a line between those two stars, and this is the cone. And then we have, of course, we have the scoop of ice cream on top. So you find that by following the arc to Arcturus. And if you follow that arc further, we arc to Arcturus, you keep right on going around the curve, and you come to this bright blue star, which is Spica in Virgo the Maiden, the sheaf of wheat she's holding in her hand. So the saying goes, you arc to Arcturus, then you speed on to Spica. And if you keep on going a little further, you come to this neat little square, which is called Corvus the Crow. So just remember, you arc to Arcturus, speed to Spica, and curve on to Corvus. Now, I find most kids don't understand what a sheaf of wheat is. So I had one little girl say, it looks like a diamond ring on her hand. I thought, yeah, it does look like a diamond ring. And crows are attracted to diamond rings or anything shiny. Might be attracted to a sheaf of wheat too if they're hungry. So to see the crow here, the way I envision this crow is this is its head. And if we give her the circle here, let's just move it out of the way here. There we go. There's a star right beside it. So think of that as its beak, and this is its head. It's flying like it's taken off. It's got a hump on its back, and this is the wing on the downbeat right here. And this is the tail down here. So he's flying up from the ground. He's got his eye on that diamond ring or the sheaf of wheat, however you like to see it, because crows are attracted to shiny things and they're hungry, so they might be going for the wheat as well. And so the crow is flying over towards Virgo's hand. So you get quite a scene there. And you can find it all by just following the arc of the handle, the curve, and arc to Arcturus and speed to Spica, then curve on to Corvus the crow. Now we can also use the Big Dipper to find Leo the lion. So let's just light up Leo again. We've already seen him. The way you find Leo is you go find that Big Dipper, and this time pretend to grab it by the handle, take the pot, and bang it down, and you'll hit Leo right smack in the back of the head. You can do that. You can always find Leo the lion. But as I tell kids, don't do that to real lions. They don't like it so much. Now, there are a couple interesting things you can find in here as well. For example, there's a cluster in here, which is a different kind of cluster. It's called a globular cluster, and it should be right about in here somewhere. Let's click on that star. That should be close. Oh, it's going to be over here, right over here. Hold on. Get it centered here. And it is right here. And it's very beautiful. This is called M5. I think it's M5, isn't it? No, M3, excuse me. I can get them mixed up sometimes. So this is M3. And you can see it looks very different than the beehive cluster. Very pretty. It looks like a lot more stars. Well, there are a lot more stars. This is M3, which is called the jellyfish globular cluster, or it's also called the rich cluster. And I think the rich cluster is probably a better description than the jellyfish. I don't know why anyone thinks it looks like a jellyfish, but that is its name. And this is about 33,300 light years away. So it's quite a ways away. Globular clusters are different than the open clusters like the beehive. Open clusters have a couple hundred stars in them, and they're all young stars. Remember I said they might be 100 to 200 million years old. Stars in globular clusters are really old stars. These stars are billions of years old, and there are lots of them. This one here has 10. They're 10 billion years old. It's the age of the sun. That's the average age. Many old stars here, and there's about 500,000 stars in this globular cluster. Globular clusters can have anywhere from 300 billion up to 300,000 to 1,000,000 stars in just a single cluster. So there's lots and lots of stars. Imagine it'd be like to be a planet going around a star in or near this cluster. How the night sky would be just lit up with thousands of suns overhead. Just a beautiful sight to look at. And if you look at it with a pair of binoculars, it's going to look like a fuzzy star. In a telescope, you'll start to discern individual stars, kind of like we're doing here. And it'll kind of look like a little pile of diamonds or a little pile of salt or sugar or something. Very spectacular to look at in the night sky. That's M3. And the way to find M3 is you find the Arcturus. And then over here, there's a little cluster, open cluster of stars, and it's called Coma Berenices. They draw this strange two-sided line for the body of Berenice. Berenice was a queen, and Coma Berenices means Berenice's hair. And I always envision this is her locks of hair hanging down from her head, and she's lying here on the couch. And I don't draw this line in. I don't get that one at all. But you can draw it the way you want. So this is her body, and these are her locks of hair. So if you can find that, all these locks of hair, they're right behind the tail of Leo the lion over here, his denobla, the lion's tail. And you'll see them. You can see them very easily with your eyes. Very pretty area to look at with a pair of binoculars or a telescope. And you go down to the other end of her body, down by her feet, and go about twice as far out, and you'll find M3 over here, the jellyfish globular, right there in the sky. Very pretty. And this open cluster of stars is just a beautiful area. These are young stars again, but behind it is also the Coma cluster of galaxies. So if you start scanning this area, you find lots and lots of galaxies. And one of my favorite ones is right here. And it's called the Needle Galaxy. Look at this one. This is an edge-on spiral as well. Now that one's really skinny. Isn't that a beautiful galaxy? This is one of my very favorites. And let me just make sure I get the facts right on this one, because it's just gorgeous to look at. We're looking edge on to it. It's also called NGC 4565. And there's a nice central bulge in the middle there. And what we find is in those bulges in the center of most of these galaxies, there's a giant black hole. We've seen that in a couple of galaxies, including our own. We have one too. And that black hole might have the mass of 1,000,000 suns or several million suns. So this place you don't really want to go. And then you see these dark areas of dust lanes and clouds and nebulosity in there. This is a 42 million light years away. And it's about 150,000 light years in diameter with about 200 billion stars. So that's about the same size as our galaxy, but we're looking at it exactly edge on. Now, when you go outside, especially in the late summer where you can see the Milky Way arching across the sky, think about the fact that you're looking edge on into the thickness of our galaxy. Now, we're inside of it. We're like right in here. If this were the Milky Way, we're in here, about halfway in. If we go from this edge, we're about halfway in and about halfway through the thickness this way. And when you look up at that band of light going overhead, you're looking right into the thickness of the galaxy. So you're inside one of these spiral galaxies. And we have a central black hole in the late summer. It's right near the horizon in the constellation of Sagittarius. We can't see it this time of year, but it gives you an idea of what it would look like if you were outside. So we have all these beautiful things in the sky you can see tonight. And you can find a lot of them with small telescopes and some of them with binoculars as well. Now, there's something else kind of interesting happening, which I can't really show you here, but I'd like to tell you a little bit about it. And that is we have a meteor shower happening this weekend. And that meteor shower is the Lyrid meteor shower. And most people are familiar with the Perseids. The Perseids happen in August every year, around the 12th of August. And the Perseids are a great one because they often have 100 to 120 meters an hour. So you can go outside, and it's in the summer when it's warm, and by August the mosquitoes aren't so bad. The kids are still on vacation. Maybe you go on a camping trip somewhere, go to like the Rangeley area or someplace like that where the skies are really dark. And if you're there along the shores of Rangeley Lake or one of the wonderful lakes up there, Richardson or wherever you like to be, and you've got a beautiful starry sky in August, you can see meteors. Every few minutes, you'll see a meteor, sometimes a couple in a minute. The ones that are happening tomorrow night, the Lyrids, only has about 18 meters an hour. When there's no meteor shower, you see 1 or 2 in an hour, maybe 3. But right now, you should see around 18 with the Lyrids, which is better than average, but not like the Perseids. But what makes the Lyrids special is there's a lot of larger meteors, which means they burn brighter, and sometimes they'll explode as they fly across the sky. So it's worth going out to see, even though you won't see as many, but the ones you see may be a little bit brighter than what you expect to see with the Perseids in August, and have a trailing tail that will kind of fizzle out a little bit and last a little bit longer. So it's a really cool one to see. Meteor showers are named after their radiant. And what that means is they're just rocks falling to the earth, or the earth is traveling through this field of rocks as we go around the sun. So they're actually falling parallel to each other. But since some are falling to our left and some are falling to our right, they look like they're coming by us one way or the other. And they all look like they're coming from one spot way off in the distance. Kind of like if you look down the railroad tracks, how the tracks seem to come together on the horizon. They don't, but they look like they do. Same thing happens with meteors. And the point where they all seem to come together, you can see them anywhere in the sky, but if you trace back the way they came from, they'd all point to a spot near the star right here, near the star Vega, which is in the constellation of Lyra the Harp. And Lyra, right there, is what the Lyrids are named after. So they're all going to be coming from the northeast in the early evening. If you want to see them better, as the evening goes on, Lyra the Harp's going to get higher in the sky. So let's go right. Remember, this is around 8:30, 8:45 tonight. If we stay up a little bit later, the stars rise in the east and cross the sky, just like the sun does, because after all, the sun doesn't move and neither do the stars. The earth is turning under our feet. And as it gets higher, the radiant is higher in the sky. So you see them, they might fly this way, they might fly that way, but they all, if you trace them back, would head towards Lyra the Harp. That's what they're named after. The Perseids all radiate from the constellation of Perseus, and the Geminids all radiate from the Gemini twins, like we saw earlier. Geminids happen in December. That's another really good meteor shower. So here we're looking at the sky. This is around 2:30, in the morning, 3 o'clock in the morning, tomorrow morning. Let's get the names off there and just look at the sky. Now, one thing that this week is all about is dark skies. And dark skies are places where there's little light pollution. Light pollution washes out the sky. This evening, I've had these stars set for what you would see if you lived in a place, not in the city, but not in a really dark spot like Rangeley. This would be like what I might have in the countryside here around Waterville or Augusta. Not in the city of Waterville or in Augusta, but out in the countryside, maybe 10, 15 miles out of town somewhere, someplace where it's fairly dark. But if you're up in the Rangeley area, you've got really nice sky, especially you get out of the town of Rangeley, get out there somewhere in one of the lakes. You know what those stars are like. They're way better than this. They're much more like this. And it's a much more intense sky and much more beautiful. It can make it a little challenging to learn constellations. That's why I have it drawn back when I'm teaching, because this busies up the sky a lot. But it sure is way more beautiful to look at. You can see much deeper into space with the telescope. You get a lot more, that light is brighter, shows up even brighter in the telescope. And you can see now we're here at 3 o'clock in the morning, and this is the sky you'd see in the early evening come July or August. And you can see our Milky Way going right overhead right here. Think about that needle galaxy and how much this looks kind of just the same as that. Wow, that's pretty cool to think about. And our central bulge is right down in here. And that's where the center of the Milky Way is, where we have a giant black hole. Now, unfortunately, we can't see the whole Milky Way in one view because the Earth always covers it up. We can see all of it over the course of a year or if you travel around the planet. But one thing we can do here is I can just get rid of the ground so you can see the whole thing. And you can see it goes all the way across the sky like this. And if I take the stars down, we can just see the band of the Milky Way without the stars and without the planets. And you see it looks very much kind of like that needle galaxy. The difference is we're kind of inside of it too. We're not totally outside. We're just looking in towards the center here. So we really need to put the stars around us, because all those stars that just reappeared, they're part of the Milky Way too, because it surrounds us. Kids ask me, how far away is the Milky Way? Well, you're in it. You can't get any closer. You can move to different parts of it, but you're in the galaxy. And so is the planet Earth. So we should bring our ground back here and put us safely back down on the ground. Well, I hope you've enjoyed looking at the sky with me here tonight. And we've moved from sunset till about 3 o'clock in the morning. If you like, we can just finish it out the night. And let's bring up the dawn, shall we? Let's bring up the atmosphere here. Oops, hold on. Where's our... Oh, you know what I did? I shut off the sun. So let's bring up, there's the sun. I guess I got ahead of myself. I turned things off so we can see the Milky Way, and I forgot I shut it off. So we're back. This is tomorrow morning, and I'm not going to go and try to do that again. I've learned my lesson. I hope you've all enjoyed the presentation this evening. I'm going to come back, and if anyone has any questions, you could have them in the chat, and I'd be glad to answer any questions you might have. And I hope you can get outside sometime in the next few days and take a look at the real sky and see if you can find some of these things. Thanks, Sarah, for hosting tonight.
Thank you. So thank you everyone for joining us, and thank you, John, for running this again. We, like I said, we have a couple more events coming up just the next couple days. So tomorrow we'll kind of be promoting our Dark Skies Trail. So there'll be more about that on Facebook tomorrow during the day. And then Sunday we'll actually have an award ceremony for the poster winners. So if you haven't gotten a chance to go and check out all the student posters in downtown Rangeley, you definitely should. We had a video up the other day of a live. It does not do those pictures justice. They are awesome. The kids at the Rangeley School did such a good job with all of those. So definitely go check those out. Check out any of the events that we've had on Facebook the last couple of days. If you haven't been able to, there's some dark sky documentaries. They're very short. I think the longest one's half an hour, but definitely check them out to kind of continue celebrating Dark Skies Week. This is our last one for a little while. I think our next one is in July. So hopefully we'll have good weather and we can do it in person for July. That'd be awesome. And then The other things that we kind of coming up soon, we'll be kicking off Walk in the Woods series again this summer. Those will be Tuesday evenings at 5. We'll do a different trail each week. So kind of keep your eye out for that. I think we started in July. I don't think we hit the end of June. But they're definitely up on Facebook. They'll definitely kind of be promoted as it gets closer. So
Cool. Well, thank you, Sarah. And I look forward to seeing you all in July. We're gonna keep our
yes.
fingers crossed for a clear night that night in late July around the new moon. And hopefully I'll be in Rangeley and we'll get out under the real stars and look at the real thing. And I hope
Yes.
to meet you in person there. So
Yeah, I
see you
hope
there.
so. Well, have a good night, everyone. Thank you so much for joining us.
Thank you. Thank you. Oh, there's one Q&A here. Let's see.
Oh, it says chat disabled.
Oh, well, I suggested they might
Mm.
ask questions. You could write a question. Right there. Hey,
Yeah,
someone
so
had
if
it
you want
with
to
you.
just type it in that Q&A part, we can certainly answer your questions there.
Nice to see you, Nancy. I'm glad you're here. I know Nancy. I guess she doesn't have a question else. I don't see anything coming in there. No.
Oh,
No
no
question.
question. Oh, let's see. I don't know if I can open the whole thing. Looks like it says just wanted to mention that it cuts off.
Oh, that's cool. The Gemini twins can be twin women too. I hadn't thought about that, but yes.
Or fraternal twins will grow what? Awesome.
Neat. I will keep that in mind the next time I talk about those. Cool. Well, therefore, that proves it. If you're a Gemini, Nancy, then that has to can be a boy and a girl. You're welcome. Great to have you here. All right. Well, I'm going to say goodnight, and I will see you on a warm summer evening, I hope, Sarah.
Yes, I hope so too. Have a good night.
You too. Take care. Good night, everybody.